Hello friends, welcome to chemistry classes by Vijay Kumar Sethi, class 11th chemistry, and now we will start the unit 10, the S block elements, and in this video we will discuss about atomic and physical properties of alkali metals. First of all, what are S block elements? The S block elements of the periodic table are those in which the last electron enters the outermost S orbital. There are two groups, group 1 and group 2, belong to the S block of the periodic table. Group 1 of the periodic table consists of the elements lithium, sodium, potassium, rubidium, cesium, and francium. They are collectively known as alkali metals. They are so called because they form hydroxides on reaction with water, which are strongly alkaline in nature, and these hydroxides soluble in water, so these are known as alkali. The elements of group 2 include beryllium, magnesium, calcium, strontium, barium, and radium. These elements, with the exception of beryllium, are commonly known as the alkaline earth metals. These are so called because their oxides and hydroxides are alkaline in nature, and these metal oxides are found in the Earth's crust. Diagonal relationship. Lithium and beryllium, the first elements of group 1 and group 2 respectively, exhibit some properties which are different from those of the other members of the respective group. In these anomalous properties, they resemble the second element of the following group. This type of diagonal similarity is commonly referred to as diagonal relationship in the periodic table. Thus, lithium shows similarities to magnesium and beryllium to aluminium in many of their properties. You can see these are the second period element, lithium, beryllium, boron, and so on, and these are third period element, sodium, magnesium, aluminium. This is the first member of group 1, okay, and this show the similarity in many of the properties with magnesium, which these two elements are diagonally situated. In the same way, this beryllium, first member of the group 2, show the similarity with this aluminium. Okay, so this is about diagonal relationship. The diagonal relationship is due to the similarity in ionic sizes and or charge to radius ratio of the elements. Now come to the group 1 elements, which are also known as alkali metals. First we will discuss about atomic properties, electronic configuration. All the alkali metals have one valence electron. So we can say their general outermost shell electron can be written as NS1. Okay, and these elements are most electropositive in nature because this one electron can easily be removed and they form positive ion. They readily lose electron to give monovalent, that is M positive ions. Hence, they are never found in free state in nature. This table shows the electronic configuration of these elements. Lithium 1s2, 2s1, sodium 1s2, 2s2, 2p6, 3s1, potassium 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, rubidium, just see the outermost electronic configuration, 5s1. In case of cesium, this is 6s1. In case of francium, this is 7s1. Now next, atomic property. Atomic and ionic radii of alkali metals. The alkali metal atoms have the largest size in a particular period of the periodic table. The monovalent ion are smaller than the parent atom. We already discussed that cations are smaller than parent atom. And the size of these alkali metals increases on moving down the group. Why? Because number of cells increases. You can see from this table, these are the elements. This show the metallic radius continuously increases. Okay? Actually, this francium is a radioactive element and its properties are not known very well. These are ionic radius. Okay, these are again increases from top to bottom. And if you compare these ionic radius with metallic radius, these are the smaller than these one. Okay. Ionization enthalpy of alkali metals. These ionization enthalpy of alkali metals are low and decrease down the group from lithium to cesium. Now, what is the reason? Because the effect of increasing size outweighs the increasing nuclear charge, and the outermost electron is very well screened from the nuclear charge. In a simple way, we can say down the group size is increases due to increase in number of cells, and also at the same time the electrons which are present in the inner orbitals, okay, they screen the nucleus to the outermost electron. Okay, that's why it is easy to remove the outermost shell electron. You can see this table. Ionization enthalpy of these metals are given in kilojoule per mole. For lithium, this is 520 and this is continuously decreases. Clear? Hydration enthalpy of alkali metals. The hydration enthalpies of alkali metal ions decrease with increase in ionic sizes. So we can say this is the decreasing order of hydration enthalpies of alkali metal ions. For lithium, this is the most negative, and for the cesium, this is the least negative. Lithium positive ion has maximum degree of hydration, and for this reason lithium salts are mostly hydrated. For example, LiCl.2H2, while sodium chloride is occur only like NaCl. Okay, and this table show the hydration enthalpies of these elements. So see, lithium most negative and this become for cesium least negative. So we can say hydration enthalpy depend on the size of cation. Smaller the size of cation, larger the hydration enthalpies. And these hydration enthalpies are negative. So we can say process of hydration, this is exothermic. Now, physical properties of alkali metals. All the alkali metals are silvery white, soft and light metals. Because of the large size, these elements have low density which increases down the group from lithium to cesium, but there is one exception. Potassium is lighter than sodium. The melting and boiling points of the alkali metals are low, indicating weak metallic bonding due to the presence of only a single valence electron in them. The alkali metals and their salts impart characteristic color to an oxidizing flame. This is because heat from the flame excites the outermost orbital electron to a higher energy level. When the excited electron comes back to the ground state, there is emission of radiation in the visible region. Now see, lithium, it gives crimson red color to the flame, sodium gives yellow, potassium gives violet, rubidium gives red violet and cesium gives blue. Alkali metals can therefore be detected by the respective flame test. Okay, with the help of flame test, we can identify these metals in their compounds and can be determined by flame photometry or atomic adsorption spectroscopy. These elements, when irradiated with light, the light energy absorbed may be sufficient to make an atom lose electron. This property makes cesium and potassium useful as electrodes in photoelectric cell. Actually, these are the cells which convert solar energy directly into electrical energy. Okay, these are atomic and physical properties of alkali metals. Thank you. Subscribe my channel In the next video, we'll discuss the chemical properties of alkali metals.